Alright, example 3. I've made 4 videos in one night. But it's been a while, and it's long overdue, and it helps me out, helps you out, whatever. So I'm going to take the inverse Laplace transform of 3s plus 1 over s cubed. So I can rewrite this as the inverse Laplace transform of, well, I'm bringing the 3 out the front. That's just s over s cubed. And then that's plus 1 multiplied by the inverse Laplace transform of 1 over s cubed. So this rule is starting to look a little obvious, so the s's can cancel out, so this is 3 multiplied by the inverse Laplace transform of 1 over s squared, and then that's plus the inverse Laplace transform of 1 over s cubed. So the rule is obviously that the inverse Laplace transform of n factorial over s to the n plus 1 is equal to t to the n, right? So that's the rule we're using. So if I've got s to the s squared, I can rewrite that as 3 to the or multiplied by the inverse Laplace transform of 1 over s to the 1 plus 1. And then I multiply top and bottom by 1 factorial. But 1 factorial is just 1, but I'm just doing it for the sake of the example. So that inverse Laplace transform is just equal to 3t. That's this part right here. Now I have to solve this part. So I'm going to bring that down here. So the inverse Laplace transform of 1 over s cubed can be rewritten as s to the 2 plus 1. So because my n here is now 2, that means my n factorial has to be 2 factorial. So I have to multiply top and bottom by 2 factorial. So my answer is now going to be equal to 1 over 2 factorial t squared. So the final answer, so f of s, well actually the inverse Laplace transform of f of s is equal to 3t plus 1/2 t squared. And that's the final answer. So yeah, just another example. So I'm obviously trying to show you how to apply the inverse Laplace transform to pretty much a few examples and a few other tricks you can do. So yep, cheers for watching, and I hope that it made sense.